Okay guys, this video lesson we're going to talk about gases, beginning gases part 1 if you will, and we're going to go through three main gas laws, Boyle's law, Charles' law, and ultimately what's called the combined gas law. So the first thing I just want to point out some things to you as we're going to look through this stuff is that you've got something called standard temperature and pressure, STP, and you kind of learned about this on your last practice worksheet, which these are the conditions of 0 degrees Celsius and 1 atmosphere pressure. And this is why it's important that when you have a gas that's at those conditions of at STP, then you can say that 1 mole is equal to 22.4 liters. This table right here, this does not apply to you. That's actually from an old book, but these are the units of pressure, all the same. These units of pressure and how to convert them, these are some things that you should be familiar with. So you should start to get familiar that 1 atmosphere of pressure is the equivalent of 760 torr. A torr is also the same as a millimeter of mercury. 1 atmosphere also can convert into pascals, so it's 1 times 10 to the 5th pascals. It can also convert into what's called kilopascals, and sometimes you'll be asked to convert an atmosphere into pounds per square inch, 14.7 pounds per square inch, or psi for every 1 atmosphere. This is the pressure that's in your tires for those of you that are drivers. That's most often what you guys see. The most common used pressure you're going to look at is the atmospheric pressure. This is measured by what's called a barometer. You also hear it as barometric pressure when you maybe watch the news, something to that effect. And then you also have something what's called a manometer, and that's going to measure pressure of an enclosed gas. This figure, again, this does not apply to your book, but I can show you pictures all the same. This right here is a really, really important point. As we get more involved into gases, you have to remember that converting Kelvin just simply means you're going to add 273 to whatever degrees Celsius you have, and that's going to give you your degrees in Kelvin. And the reason you need to know this is because all gas calculations, you must express the unit of temperature in Kelvin. You cannot use Celsius. A lot of times you'll be given Celsius, but you can't use that one. These points F and G we're going to come back to later on in the course. This is not for right now, so I'm just going to go ahead and move on to the first gas law that I want to talk to you about today. So this first gas law is called Boyle's gas law, and this just says that you have a given amount of volume. You're at a constant temperature, so that's not affecting that. You're going to have an inverse proportion to the pressure. So what that means is that pressure is proportional to 1 over the volume, right? Which, when you look at this graph here, you see you have pressure over here and volume, and here you have volume over 1 over the pressure. And so what this basically means is as you would increase your pressure, then that means you're decreasing in the amount of volume. And then the reverse is true. If you're decreasing in pressure, then that means you're increasing in volume. So as one goes up, the other one goes down. And I'll show you some examples. There's an example problem here in just a second. Okay, so the pressure of a fixed amount of gas doubles. So the pressure is doubling. So let's say pressure 1 is doubling. What happens to the volume? So it's going to be half. So let's say P1 was simply 1, and let's say P2 doubled to 2, and then let's say V1 was equal to 1, then we want to know what is your second volume. you theoretically can just conceptualize this and realize that if you're going to double the pressure, then you should end up with half the volume. But just to show you the equation, if you've got P1 times V1 equals P2 times V2, then you would essentially have 1, all right, for pressure 1, volume 1 is 1, simple numbers here, pressure 2 is 2 times V2, and then if you solve for V2, you would get 1 half. So you see how that works? As you double one, you would half the other. Increase one, you decrease the other. Similar law is Charles' law, although it's not on your practice per se, but it's basically doing the same thing, just relating volume and temperature. But in this case, you have volume is directly proportional to temperature. So just as you solved the problems up here for Boyle's law, if you were increasing volume, then that means you're also increasing temperature. Likewise, if you're decreasing volume, then you are decreasing temperature. Okay. And this is just showing you, this is a little graph here, just showing you volume versus temperature, and again, it's directly proportional. And this is just kind of giving you an idea to look at different types of gases and where they stand in relation to each other. Okay, so again, if we're looking at temperature of a fixed amount of gas, it's doubling. So temperature doubles here from 20 degrees to 40 degrees Celsius. What happens to the volume at constant pressure? Well, then that volume would also double. All right, because remember they're directly proportional. Another law that you need to understand is what's called Gay-Lussac's law. And Gay-Lussac's law is representing or showing you pressure and temperature. And so what this is saying is that pressure, in this case, is also directly proportional to temperature. Therefore, if you are increasing the pressure, then you are also increasing temperature. Likewise, if you're decreasing pressure, then you are also decreasing the temperature. And so if you have, in this case, the temperature of a fixed amount of the gas doubles, so again, the temperature is doubling, what happens to the pressure? Well, then that pressure would also double. Okay? Okay. Moving right along here. I'm going to extend this a little bit. Okay, so let's look at how we look at what's called combined gas law. Combined gas law, as you guessed it, is going to combine all three of the previous gas laws. This equation here, this is what's called the combined gas law equation. You should memorize this equation, know how to use this equation. It's just simply saying that the pressure, the first pressure of a gas times the first volume of a gas divided by the first temperature of that gas would be equal to the second pressure of the gas, second volume of the gas divided by the second temperature. Sometimes students like to rewrite this equation and remember it. If you do a cross multiplication, and then you could say P1 times V1 times T2, okay, would be equal to P2 times V2 times T1. And if that helps you, then by all means do whatever helps you to solve the problem that you would need to solve. So let's look at this example here. We're going to look at this example here. So you have a weather balloon on the ground contains 25.8 liters of helium. This is helium gas. Right, at 29 degrees Celsius and 741 torr. What is the volume of the balloon when it rises to an altitude where the temperature is 11 degrees Celsius and the pressure is 535 torr? Okay, so some things to identify in this problem. This 25.8 liters, this is your first volume, right? That's your V1. 29 degrees Celsius, this is your T1, your first temperature. And then this right here, this 741 torr, this is your P1. So you've got your P1, your V1, and your T1, okay? What is the volume here? We're solving. So this is what we're solving for, is this volume, right? V2 rises to an altitude. The temperature now is 11 degrees Celsius. This is your T2. So now we've got that T2. And then the pressure, this is now your P2. Now you've got that. So you see here you've got 5 of your 6 variables, and you can just algebraically manipulate this equation. So let's take a look at that. Okay. Oops. Okay, so again, if we're solving for V2, remember we took the original equation was P1 V1 over T1 is equal to P2 V2 over T2, right? That's what this equation is showing you right here. Or you may have decided to say, okay, P1 T1, excuse me, P1 V1 times T2 is equal to P2 V2 times T1. And then if we were going to divide both sides by P2 and T1, because we're trying to get your second volume, right? Therefore, we would now know that pressure 1 times volume 1 times temperature 2 divided by pressure 2 times temperature 1 is equal to V2. Right? And that's because up above here, this pressure canceled, this temperature canceled, left us with just the volume 2, which is what we have here. That's what we want. And now all you need to do is plug in your values. So you've got your pressure 1, you've got your volume 1. Oh, important point. I almost forgot. Right here, notice what's going on. In the problem that was given to you, your temperature was given to you in Celsius. And if you recall, I told you all gases must be in the units of Kelvin. So you have to convert that temperature in Celsius into Kelvin. You just add 273. You can do this in the problem, or you can do it separately and then put it in. Either way. But you're also doing it, remember, for your second temperature. Important points to catch out. The pressures, here you have pressure 2 is in the unit of torr, and then the same thing, pressure 1 is in the unit of torr. It's okay as long as they're the same on both sides. So as long as this is in torr, then that unit must be in torr. You can't have a pressure 1, for example, be in atmosphere, and then pressure 2 be in torr. And that's pretty much it. And now you're just solving for V2 to get by itself, and in this case we solve it and we find that it's 33.6 liters, and that's in liters because your first volume was in liters. If it was the first volume was in milliliters, then your answer would have come out in milliliters. Okay, so that is how you solve for different types of gas problems: Boyle's law, Charles' law, and combined gas law.